Chapter 8 Kubernetes Building Blocks Introduction and Learning Objectives Introduction. In this chapter, we will explore the Kubernetes object model and describe some of its fundamental building blocks, such as pods, replica sets, deployments, namespaces, etc. We will also discuss the essential role of labels and selectors in a microservices-driven architecture as they logically group decoupled objects together. Learning objectives. By the end of this chapter, you should be able to describe the Kubernetes object model, discuss Kubernetes building blocks, pods, replica sets, deployments, namespaces, discuss label and selectors. Kubernetes object model. Kubernetes has very rich object model, representing different persistent entities in the Kubernetes cluster. Those entities describe what containerized application we are running. Second, the nodes where the containerized applications are deployed. Third, application resource consumption. Fourth, policy attached to applications like restart, upgrade policies, fault tolerance, etc. With each object, we declare our intent or the desired state of object. In the specs section, the Kubernetes system manages the status section for objects, where it records the actual state of the object. At any given point in time, the Kubernetes control plane tries to match the object's actual state to the object's desired state. Examples of Kubernetes objects are pods, replica sets, deployments, namespaces, etc. We will explore them next. Creating an object, the object's configuration data section from below the specs field has to be submitted to Kubernetes API server. The API request in create an object must have the spec section describing the desired state, as well as other details. Although the API server accepts object definition files in a JSON format, most often we provide such file in a YAML file format, which is converted by kubectl in a JSON payload and sent to the API server. Below is an example of a deployment object's configuration manifest in YAML format. The API versions field is the first required field. It specifies the API endpoints on the API server, which we want to connect to. It must match an existing version for the object type defined. The second required field is kind, specifying the object types. In our case, it is deployment, but it can be pod, replica set, namespaces, servers, etc. The third required field, metadata, holds the object's basic information, such as name, label, namespace, etc. Our example shows two specs fields, specs and specs template spec. The fourth required field, specs, marks the beginning of the block, defining the desired state of the deployment object. In our example, we are requesting that 3 replica or 3 instances of the pod are running at any given time. The pods are created using the pod template defined in spec. Template a nested object such as the pod, being part of a deployment, retains its metadata and specs and loses the API version of and kind, both being replaced by template in spec. template spec, we define the desired state of the pod. Our pod creates a single container running the nginx 1.15.11 image from Docker Hub. Once the deployment object is created, the Kubernetes system attaches the status field to the object and populates it with all necessary status fields. Pods. A pod is the smallest and simplest Kubernetes object. It is the unit of deployment in Kubernetes, which represents a single instance of the application. A pod is a logical collection of one or more containers, which first are scheduled together on the same host with the pod. Second, share the same network namespace, meaning that they share a single IP address originally assigned to the pod. Third, have access to mount the next external storage volumes. Pods are ephemeral in nature. Pods are ephemeral, which means short-lived in nature, and they do not have the capacity to self-heal themselves. That is the reason why they are used with controllers which handle pod replication, fault tolerance, self-healing, etc. Examples of controllers are deployment, replica sets, replication controllers, etc. We attach a nested pod specification to a controller object using the pod template, as we have seen in the previous section. Below is an example of a pod object configuration manifest in YAML format. API version v1 kind pod metadata name label spec container then image port. The API version field must specify v1 for the pod object definition. The second required field is kind, specifying the pod object type. The third required field, metadata, holds the object name and label. The fourth required field, specs, marks the beginning of the block, defining the desired state of the pod object, also named the pod spec. Our pod creates a single container running nginx 1.15.11 image from Docker Hub. The container port field specifies the container port to be exposed by Kubernetes resources for inter-application access or external client access. Labels. Labels are key value pairs attached to Kubernetes objects, such as pods, replica sets, nodes, namespaces, persistent volumes. Labels are used to organize and select a subset of objects based on the requirements in place. Many objects can have the same labels. Labels do not provide uniqueness to objects. Controllers use labels to logically group together decoupled objects, rather than using object names or IDs. C. App Frontend Environment Development. C. App Backend Environment Development. C. App Frontend Environment Quality Assurance. App Backend Environment QA. In the image above, we have used two label keys, app and env. Based on our requirements, we have given different values. to our 4 parts. The label env equal to def logically selects and groups the top 2 parts, while the label app equal to frontend logically select and groups the left 2 parts. We can select one of the 4 parts bottom left by selecting 2 labels, app equal to frontend and env equal to QA.